Hello, and welcome to another episode of Decentralounge, brought to you by Global Stake, your institutional, truly decentralized, self-owned, and managed SOC 2 Type 2 compliant bare metal staking service provider. Today, we're excited to host Dr. Alexei Zamyatin, the co-founder of Interlay, and Bob, Built on Bitcoin. With a PhD in cryptocurrencies and security engineering, Alexei has a profound background in blockchain technology, focusing on its intersection with security and decentralization. At Interlay, he led the initiatives to create interoperable blockchain solutions that enhance Bitcoin's utility without compromising its core principles. But on Bob, or Build on Bitcoin, it further emphasizes Alexei's commitment to expanding Bitcoin's ecosystem through innovative applications. Join us as we explore the cutting edge in developments at Bob and delve into the challenges of building on Bitcoin and discuss Alexei's vision for the future of interoperable blockchain technologies. Alexei, thank you so much for taking the time today. We're excited to have you here on the show. Long time waiting for this moment to happen. So why don't we just start off a little bit about your background and what got you interested in Bitcoin from the very beginning?
Hey, thanks for having me. I'm Alexei. I'm one of the co-founders of Bob. I'm a computer scientist by trade, even though I unfortunately don't get to code as much anymore. I got into Bitcoin mainly by coincidence. I was working on T-security research, looking to, obfuscate Tor traffic behind Skype traffic. My supervisor also offered Bitcoin-related topics during my bachelor's thesis, so I kind of switched. Naturally was very excited about not just the currency and financial aspects of Bitcoin, but specifically the decentralization and the censorship resistance. Got into Namecoin, found that super exciting as an application beyond just payments. And from there, it's been a bit of a random walk of research over the next couple of years. Worked on color coins, merge mining, decentralized mining pools. Payment channels. Spent some time, I guess, on Lightning and quickly figured out that this is probably not what's going to scale Bitcoin. Specifically, it wouldn't allow us to do more than just payments. And I never believed that payments was the only thing Bitcoin should be used for various reasons. And ultimately, by coincidence, again, got a PhD position, was doing a research internship at Imperial, and blockchain.com was essentially funding this position to initially look into Lightning. And then after this whole, civil war that happened on Bitcoin, they together with us kind of suggested, okay, well, Bitcoin isn't changing. I had, to be fair, by that time, long accepted that we're not going to see any smart contract functionality, and the changes to Bitcoin are very slow and difficult, so we shouldn't rely on them as much. And we started then looking into bridges and how can we build sidechains around Bitcoin in a trust minimized manner? How can we get Bitcoin security, and how can we actually bridge Bitcoin over to these systems? That I have been doing for the last 5, 6, 7 years now. And I think it's fair to say that Bob is like a culmination of all of these efforts and our experiments and experiences within the Bitcoin ecosystem, but also building on Ethereum, building on Polkadot, building with other ecosystems as well, and drawing lessons learned, and figuring out a way that we feel is really going to get us to a scalable and trust minimized DeFi, or like decentralized financial ecosystem built on top of Bitcoin, and bringing that, like, with the goal to bring the innovation back to BTC. And that's what essentially Bob is. Bob is our approach to solving this problem, the bridging this chasm between Bitcoin's adoption and the innovation we see in other ecosystems.
Well, that makes a lot of sense. And, going back, speaking of your research background, I know that the big part of it was sort of the X claim, this idea that goes back to, I want to say it was 2018 or 17, somewhere around there, where you produced the paper kind of theorizing about how these bridges could actually work in a trustless manner. So maybe we could dig into that a little bit and explain, because that's the big thing, right? That everybody talks about, where with bridges, that they're never trustless completely, or there's always going to be some kind of problem, because a lot of times bridges have maybe multi-sigs on the other end, and there's like honeypots of funds, so on and so forth. So what really, maybe dig into that idea a little bit, and how that kind of pushed you forward with your research and building out all these solutions.
So if we think about Bitcoin bridging, in bridging in general, there's a spectrum of different solutions and their trust assumptions. And one thing to state here is that building bridges between two blockchains requires some trust by design. Of course, you trust the two chains, right? If you're bridging two chains and one of them breaks, naturally the bridge is going to break. I mean, if you even imagine it like a bridge between two cliffs and one of them falls, the bridge is gone as well. So that's easy. But then the other aspect here is that no matter how you design your bridge, we've proven actually as part of like actually there's a formal proof that as part of my PhD that when we bridge to different chains, there's always someone we have to trust, that you cannot get rid of some form of trusted third party. This goes back to some very, very old hard problems in computer science. But in practice, what we can do is this trusted third party can be represented by either one of the two chains. So if the chain is kind of sentient in the sense that it can actually, it specializes maybe in bridging and kind of, the bridge is part of the core protocol, core consensus of the chain. So you can abstract it and kind of merge that additional trust assumption into, okay, it's just the two chains, or you can allow anyone to become this trusted third party in specific bridge designs. Now, when we think about these bridge designs, the simplest one is, okay, on the far end of like the more trusted kind of spectrum is you have a single entity, right? Like BitGo with WBTC. Sure, BitGo has an MPC-based wallet in the background, and they have it's distributed across multiple signers, but you trust BitGo. And then you have that's a classic multisig wallet. You probably see, right? The team has a multisig. And then you have like a bit of an improvement where you distribute that trust across different entities, where you have, again, cryptographically speaking, it's hard to prove that they're really different, but in real life, okay, there's different companies, different individuals. Okay, that's already a bit more secure. Like you have maybe not one signer, but you have multiple custodians that kind of hold the Bitcoin together. And of course, it gets even better if you scale that signer set. So you can then use MPC protocols because on Bitcoin, we can only do so many multisig participants in a vanilla plain multisig transaction. So what the step there is take it off chain, scale the signers, and you can scale to a few dozen, maybe even a few hundred in theory in the future. This is what TBTC v2 is doing, right? Where you use threshold signature protocols. And essentially, it's the same. It's a multisig, but it's just a bigger multisig. And all of these have the assumption that the majority of participants is honest. If the majority is dishonest, they're going to steal your money, right? That's it. There is no protection against a dishonest majority of signers. And on the far side of the spectrum, right, and this does not work for Bitcoin, right? Bitcoin stops at somewhere in between because there's only so much you can do Bitcoin script. But in the ultimate case, you would say, well, okay, then we don't want to trust anyone in particular, but we'd have two blockchains and they could verify each other. This is called a so-called light client bridge. So in the ideal world, we would have, let's say, Ethereum and Bitcoin, right, or Bob and Bitcoin, if we're talking about Bob. So Bob would verify that a minting transaction was done on Bitcoin. So when you're bridging in, or like a bridge transaction deposit was made on the Bitcoin side. So somebody sent Bitcoin to something, right? Let's ignore what that something is, what this deposit, like a contract. And you automatically, because Bob can verify this cryptographically, right? So Bob runs a light client for Bitcoin, checking block headers, checking, okay, this is the longest chain. Oh yes, there's this transaction that contains a bridge in. Let's create this wrapped Bitcoin on Bob. And this part already works, right? This is possible because Bob has smart contracts. Bob can verify Bitcoin. Okay, that we have. But on the flip side, when you bridge back, so when you're bridging Bitcoin back to the Bitcoin chain, what you would like to do is that Bitcoin looks at Bob and says, oh, somebody burned one wrap BTC on Bob to get Bitcoin on the Bitcoin chain. Let us unlock this Bitcoin to that user. Now, in the ideal case, what we want to do is that all Bitcoin full nodes look at Bob, say, oh yeah, Bob burned the wrap, somebody like Alexei burned wrap BTC on Bob. So Alexei should get one Bitcoin on the Bitcoin blockchain. And that's where it gets tricky because Bitcoin cannot do that. Bitcoin scripting capabilities don't allow us to practically implement these light clients for other networks. So Bitcoin is blind to other networks. There is currently no easy way, and I'll come to that in a second, how to do it in practice with BitVM, but there is no easy way to do it on-chain. Like as a smart contract or script on Bitcoin doesn't work. So that's a limitation. And then previously, because you mentioned the Exclaim design, what we then found is, okay, well, if we cannot, enforce it on Bitcoin, if we cannot enforce this behavior as a smart contract, What we could do is use economic security. So we kind of say, okay, what's the next best thing if we can do instead of having all Bitcoin full nodes enforce it? Well, we could say, okay, we don't care how you as a node operator, bridge operator, manage the Bitcoin, but I'm going to make sure that you have zero incentive to steal. And the way to do this is applying the same principle that we see in DeFi. That's over collateralization. So in the Exclaim design, and that's also what we implemented on Interlay in the Polkadot ecosystem, you would first, as an operator, you would lock up collateral in a basket of different assets, which are not Bitcoin, right? Ideally, like the native asset or the protocol, stable coins, other assets. And if you lose the Bitcoin or you steal it, then you get liquidated. And because Bob or Interlay or any smart contract capable chain can verify what's going on Bitcoin, it's very easy to show, like, wait a second, you should not have withdrawn that Bitcoin. You should not have moved it at this point, or you're failing to service a redemption request. Now, since you failed to do that, we're going to take your collateral instead and reimburse the user. And the system is secure as long as the value, the dollar or whatever Bitcoin denominated value of that basket of collateral is worth more than the Bitcoin that you're holding, right? So as long as the economics here work, right, as long as you're going to lose money by stealing, you're not going to steal. That's a very secure design. It's very simple in that case, because on Bitcoin, you only do a normal Bitcoin transaction. There is no complex scripting, no complex kind of MPC protocols that you need to run. The logic is on the smart contract side, but it doesn't scale as well, because now when we wrap Bitcoin, right, we lock up Bitcoin, we get the wrap Bitcoin. Okay, so it's 1-to-1 backed, but you also have, let's say, 1.5x amount of collateral in different assets that also need to be locked up. And unfortunately, that doesn't really scale that well, because for, let's say, securing $1 billion worth of Bitcoin, it would need $1.5 billion worth of additional assets locked up. Now, it could scale if we use things like restaking and are able to reuse that collateral and stake it into some assets, like stake it onto Ethereum, stake it into DOT and other protocols, and basically reuse it to, reduce the capital costs and counter that. So essentially you have less opportunity costs on the capital that you're locking up in the bridge. And I think we've seen some attempts already with Eigenlayer to do so, and this can work indeed. But still, the capital costs are there. And this brings us to something that I've personally spent many, many years looking for and didn't find until Robin essentially came up with the idea of BitVM. And that's why although we were first quite skeptical about how it was sold, after and Robin was so kind to spend a few hours with me on calls, we're very quickly convinced that this is indeed the best solution, because what we can do with BitVM is create a like client to like client bridge. So what we can do is say on Bitcoin, we're going to verify that somebody burned the wrap BTC on Bob. So now we still cannot do this on chain. That's the problem we're facing, unless we fork some additional functionality into Bitcoin. But what BitVM allows us to do is it allows us to take this computation off chain, right? And very similar how Arbitrum or Optimism work as rollups on Ethereum, where you basically move your assets to the L2, you do something, and then that, okay, if something goes wrong, there'll be a fraud proof. BitVM is the same thing. BitVM allows us to do fraud proofs on Bitcoin. That's basically, there's no like virtual machine built into it. You can run any program, commit to the results, and so commit to the program, and then you commit to the result on chain on Bitcoin or somewhere else, doesn't matter. And people can challenge you if they disagree. And then you actually have a chance to disprove that the computation was done. And only this part, the actual fraud proof, is executed on Bitcoin. And typically, if you have a big program, right, how fraud proofs work is you only actually need to execute a small chunk, the place in the program where you're manipulating it to, change the results. So let's say I committed to multiplying 2 times, running a multiplication, and the multiplication you ask me to do is 2 times 10. Now, what I tell you is 19 as a result, which is obviously wrong. Everybody can verify that. Now you need to disprove. And you see that in the last step, instead of adding 2, I only added 1. So you just actually show me that, wait, in this last piece of like a computation, this part is wrong. And that's the whole idea of fraud proofs in general, not just specific to Bitcoin. You take the full program, you commit to it, you run it off chain, and then when there's a dispute, you just find the exact place where the computation went wrong, and you show that, and you just run this specific part of the program. And since that specific part of the program is only small, or can be as big or as small as you want it to be, that we can actually fit into Bitcoin transaction. And the last thing, before we can talk more about BitVM2 and how it works in detail and step by step. But the important thing to kind of note here is many people don't know that in Bitcoin script, we can actually implement any program. You can use Bitcoin script to basically for universal computation. The problem is, however, Bitcoin size, and specifically the block size and the stacks limit. So Bitcoin, think of it, for those familiar with computer science, you have high level and you have lower level programming languages, right? You have like assembly, which is very low level, where you really just, like you're pushing to the stack. And that's what Bitcoin Bitcoin is very similar to that. Like you're pushing items to the stack, you're manipulating the storage, and then you can't do much. So even things like multiplication, you have to implement yourself. Whereas if you're using Python, JavaScript, whatever, Rust, you just call it like multiply, right? And then in the background, this is done for you. The problem with Bitcoin is essentially that if you can build anything, but the size of the program grows because you have to build everything yourself, even multiplication. And that means that, let's say, if we want to implement the holy grail, of course, is having ZK verification. So if you want to implement a ZK verifier in Bitcoin script, that thing is over a gigabyte in size, at least 1 to 2 gigabytes, even with best optimizations. Sure, it's in Bitcoin script, but it doesn't fit into a block, and that's why we need this optimistic verification. Unless we fork some operations into Bitcoin, and that could be a way to cut down the size. If you can, say, okay, well, you don't have to implement multiplication yourself. Okay, that already reduces the amount of like lines of code you can think about that, in that program that you need to write in script. And BitVM takes the other route and says we don't need a fork. We'll just execute it off chain, and then you'll just run only a small piece of the program in case something goes wrong. So that's essentially this kind of rather long answer to a simple question. But bridging is a very hard topic. You always need to trust a third party. Best thing you can do is like client bridges, where the only thing somebody in the network needs to do is like submit the data, like, hey, here's a proof. And previously on Bitcoin, we couldn't do that. So we used economic security, where you would collateralize the operators. And if they lost the Bitcoin, they would liquidate it and they'd lose the collateral. And that collateral was reimbursed to kind of make sure victims don't actually have financial damage. And now with BitVM, specifically with this newer, more practical version, BitVM2, we are actually able to implement this like client to like client bridge. Things that you see, for example, in Cosmos and Polkadot, right, where you can actually the chains can talk to each other. This is now possible on Bitcoin. Finally, after so many years of research.
Well, that was an incredible in-depth answer. And, as someone who's a Bob user, for instance, like I totally understand now, like the one-click staking and what's actually happening behind the scenes, as I'm the least technical person on our team, but I love just messing around with various protocols. And I've been a big fan of Bob since day one. So like part of your answer totally made it just really clicked in terms of what's happening behind the scenes with the one-click staking. Maybe we should dig into a little bit about why you chose sort of the OP stack and, kind of position Bob as sort of a hybrid L2. And I was explaining to Jordan before we got on and started recording a little bit about what Bob is doing. And so maybe get into the rationale behind why you chose that particular tech stack and what it helps enable, just with some of these things I think you already discussed in just the previous answer, and maybe talk a little bit about where we are in terms of getting to that place with BitVM and how Bob's going to help enable that.
Absolutely. So there's two ways of like answering this question. I'm gonna go with first like explaining what the hybrid L2 is and then why we're doing it. So the hybrid L2 design is a new way of thinking about layer twos. It's a new type of Bitcoin secure blockchain. And the idea is that the hybrid L2 inherits security from Bitcoin and then uses this property to build trust minimized bridges first to Bitcoin, but then also to other layer 1 blockchains. And this removes the need for any third-party bridges and also counters the fragmentation of Bitcoin liquidity across multiple different chains. As we see it today, you're wrapping Bitcoin to all the different networks, and inverts it in the sense that, okay, we have something, a chain that it has Bitcoin security, native Bitcoin, right, using a trust minimized bridge. You, instead of like going from like wrapping Bitcoin to Ethereum, you deposit it from Ethereum to that layer 2. But that layer 2 has Bitcoin security, and your bridge from ETH to that thing to Bob is also secured by Bitcoin. And the thing that we leverage here is essentially that A, if there's one thing that everybody in crypto can agree on, is that Bitcoin is secure. That's the easiest thing to sell, like everybody agrees. And two is that, if you recall, we talked about light client bridges. Bitcoin light clients, Bitcoin has a secure and very simple light client. Very few other chains have that, right? Building provably secure light clients is very hard. Ethereum's light client is not provably secure, right? Doesn't really scale, doesn't work as a smart contract that well. But Bitcoin is easy. Ethereum can verify Bitcoin, Solana, Tron, Polkadot, Cosmos, anything. They all can easily verify, oh yeah, that Bitcoin transaction happened. So now the idea is, well, if Bob has Bitcoin security and finalizes on Bitcoin, if I'm depositing from ETH to Bob, I only need to check that, hey, did this thing finalize on Bitcoin? And that's very easy to implement. And yes, you have to trust that Bitcoin is secure, but that's the easiest trust assumption we can make in practice. So what we do is we basically achieve two things. We, of course, leveraging the new developments in BitVM, we build a system that inherits Bitcoin security, and I can talk about the way to get there in a second. But we also solve the interoperability problem, and we solve it in a way that probably nobody has thought about it so far. Is we built even like things like Polkadot, Cosmos, build their own ecosystems of interoperable chains, like Avalanche Near copied that design. Ethereum is following in that direction with its rollup-centric roadmap. But we can essentially use Bitcoin as a trust anchor. And that's what the hybrid L2 does. Instead of saying, oh, let's spin up dozens of chains around Bitcoin, the hybrid L2 idea is, well, okay, here's the hybrid. It has Bitcoin security. Anyone can connect to it as long as you can verify Bitcoin. Well, okay, just like you all deposit your assets into Binance, trade and withdraw to whatever layer one you like to go back to, you can just do that in the hybrid L2 that is Bob. You can deposit from Bitcoin, from ETH, from Solana, from Tron, from whatever, trade it against each other's stablecoins, and withdraw to whatever L1 that you like to go back to. Which, as you can see, positions Bob not only to compete on the L2 arena, but actually to go after the way we see DeFi today, and specifically also competing with CeFi players, because we can offer a similar service, but instead of trusting a centralized provider, you trust that Bitcoin is secure. So that's kind of this long-term vision. Obviously, initially we care mainly about Bitcoin and Ethereum being the two major ecosystems. But the cool thing about this is once we have the design ready for ETH, any chain can just easily connect to Bob. And the only thing you need to do is run a Bitcoin-like client. And I can probably say with high certainty, like almost all modern smart contract capable blockchains already have or can easily run a Bitcoin-like client. So in short, hybrid L2, Bitcoin security, trust minimized, Bitcoin secure bridges to all the other networks. You don't need trusted third-party bridges. And we kind of get around this impossibility of bridging by just using Bitcoin as a trust anchor and leveraging the simplicity of its light client that everybody can verify Bitcoin. And the reason why we actually are going for hybrid design and not just a Bitcoin L2, focus on Bitcoin only, is that we learned the hard way, I think, in the past, that tech is not the only thing that, makes you win or lose. And that it's not just about the tech, it's about the usability and essentially also building an ecosystem. And the way we think about it is when you're building a Bitcoin layer 2, there's three things you need to solve. One is the security and the bridging aspect, and we spent a lot of time talking about it already in this call. But there's two others. The second one is the ecosystem problem. You need to make sure that your dApps are considered to be your clients and they are successful, because if you're not successful, if the dApps, your clients, are not successful, your platform is not successful. And so you need to provide them with the best-in-class infrastructure. You need to provide an environment where the choice to build on Bob versus somewhere else is easy, because the infrastructure is all there. And that's the case for Bob today. There is no difference between building on Bob, Optimism, or Base. The infrastructure is the same. The tooling is the same. It's best in class, and it's easy to start. And then, that's when we can then excel in the Bitcoin side of things, which nobody else is focusing on and can deliver on that level as Bob. And that's been basically the selling point. Versus if you say you don't have that kind of infrastructure and you force teams to build the infrastructure themselves, they lose time on basic things that are available out of the box on Ethereum. And essentially that makes it very hard for them to compete, because they're wasting time not building the product, but building basic things. And that makes it very hard for teams that build on, unfortunately, if you look at it today, non-EVM ecosystems, dApps that build there have a strong and major disadvantage over dApps that build in EVM ecosystems, because these just benefit from this multi-billion-dollar industry that already exists and allows you to tap into this best-in-class infrastructure and tooling. and power users. Like power users in DeFi are EVM natives. So for them, it's much easier just to use the same things and like move their assets around if it's EVM rather than installing a new wallet. And it's all new and it all looks different and the names are different and it just is hard to get started. So that's to ecosystem, right? And on Bitcoin, that's even harder because Bitcoin just, until today, the usability of Bitcoin, if you compare it to Ethereum, it's like, right, I couldn't even like fit it into the screen here. And in our opinion, the first thing Bitcoin LTs need to do is level the playing field, right? If Ethereum is always up here and you're starting to rebuild from scratch, Ethereum's not going to slow down. It's just going to keep accelerating and you're never going to catch up. But if you level the playing field and suddenly have the same infrastructure, same tooling, and you just take what Ethereum already invented, you accept that Ethereum did a really good job at a lot of these things, but you can, and then you level the playing field, that's when you can start competing because you can offer as Bitcoin, so you can actually offer something else. You're offering access to Bitcoin products, access to a much bigger, much wider community, access to 300 million users worldwide with Bitcoin's brand recognition that challenges even that of Apple versus an arbitrary optimism that people don't know about outside of our Web3 bubble. And last but not least, it's liquidity. Yes, Bitcoin has a lot of dormant liquidity. And yes, we could take the EVM, we could fork it, launch a standalone isolated chain, build a decent enough Bitcoin bridge, get Bitcoin into that chain, and then what? That's been tried in the past without, pointing fingers and highlighting things that didn't work. That's been tried in the past. There's a reason why there's this new surge of Bitcoin layer 2s because some of the existing ones didn't solve this problem. Building in isolation is deadly. Network effects, especially in our industry, matter a lot. This means if you're an isolated chain without connections to other networks, without access to centralized exchanges, to institutional custody, to on and off ramps, you're going to have a very hard time because what are you going to trade Bitcoin against? Native assets? Sure, if you're able to bootstrap out of nowhere a meme coin, and that it is possible. Solana is probably one of the examples that did well, but they also had a lot of money invested into infrastructure. And it took them a long time, and that's one out of how many tens of thousands of chains that succeeded in this. And it's still far behind Ethereum. But okay, that's probably a success example that can work. But they were very smart in how they invested. They had a lot of money put into that ecosystem, a lot. Not everyone has that ability and access to that kind of money. And where the money comes from is another question. But they made the best out of it, and they actually did a pretty good job. But otherwise, we had enough examples where chains are isolated and they just die. And that's why Bob is a hybrid, because we can connect to Ethereum. We accept Ethereum as the innovation and DeFi that it is today. And we bootstrap using Ethereum, just like other ETH02s are doing, which means liquidity can flow easier, which means we have access to all the exchanges, right? You've seen first tools where you can just go from an exchange directly to the L2 without even doing an intermediary bridging transaction, right? So just withdraw from Binance directly to Bob, even without Binance or Coinbase directly supporting it on day one. Eventually, as you grow, all these integration problems go away, right? If you're big enough, every exchange will support native withdrawals, but you have to get there first. And that's why bootstrapping is so difficult. This cold startup problem exists for a reason. Like, it's a problem for a reason. And the hybrid L2 approach solves this because today Bob is an ETH rollup. We're OP stack, we're Superchain member, we benefit from all the best-in-class infra, access to liquidity, stable coins from Ethereum. And no other Bitcoin L2 has that because everybody's too scared to say, oh, we're going to connect to Ethereum because it's not Bitcoin only. But we're pragmatic and we say, okay, well, look, instead of me running Bob as a multisig, isolation, well, Ethereum security is better than just some multisig anyway, because realistically speaking, BitFam is not production ready yet. So 99% of the Bitcoin to today will be multisigs initially, which is fine, right? That's okay. But if we're thinking pragmatically, I'd rather connect to Ethereum and be part of this large ecosystem there where they're all Bitcoiners. All the DeFi users have Bitcoin, they just can't use it in DeFi properly. And we solve that problem for them with this one-click staking by enabling new Bitcoin DeFi primitives, and use that to bootstrap, to grow the ecosystem, go to market. And in parallel, we gradually add Bitcoin security, where we then can roll out BitVM on the bridging side. There's different types of Bitcoin security that does not require full verification on Bitcoin, right? There's a problem of with rollups, you have to post data to the chain. That's very expensive. doesn't yet scale on Bitcoin. So, you might have to find a middle ground approach initially until you're big enough. And that's the thing, until you're big enough. Once you're big enough, you can afford to post all your data to Bitcoin, run an optimistic rollup using BitVM2, and that's all fine. And you actually have solved the problem. But you have to get there. You have to be able to afford these millions of dollars in fees on Bitcoin as a chain without, charging users a 10 or 100-fold of what they would pay on Arbitrum. And that's why Bob's hybrid approach is not just about connecting to different chains and bringing innovation back to Bitcoin, but it's also a way of rolling out a new ecosystem gradually by being pragmatic, bootstrapping from Ethereum, and then gradually plugging in Bitcoin security, Bitcoin one-click staking on products, and so on, to use Bitcoin then to grow. Because that is something that a Bitcoin L2 has that ETH02s don't have. Access to Bitcoin, trust minimized access to Bitcoin, the Bitcoin umbrella as an ecosystem where, for the Dune fans out there, right, the Ben and Gesserit have, they were operating on Arrakis, preparing kind of the community there for the arrival of the Messiah. I'm not saying Bob's a Messiah, right? But Bitcoin L2s could be. And there you go, right? You actually then can the Bitcoin community has been prepared for the arrivals of L2s. But they only had Lightning so far, which doesn't really solve a lot of these problems. But now with better technology, and of course, a lot of that technology was developed first on Ethereum, but who cares, right? Doesn't matter. With the arrival of this new technology, the advancements in UX, smart accounts, intents, smart wallet, all these things that you can do now on Ethereum, with things like BitVM, you will eventually have them on Bitcoin. And that's when you then can really benefit from what Bitcoin has achieved on a global scale with adoption, penetrating every single sector, and having a brand recognition that, as mentioned before, challenges that of Apple. If you see the Apple logo, you know exactly what it stands for. You show someone a Bitcoin logo, they know Bitcoin. Whereas only 35% of people hold digital assets, many, many more know Bitcoin. Very few know Ethereum comparatively, and anything else, forget it, right? But Bitcoin, they know. And that is something. That's the rails you actually need to take crypto mainstream, because Bitcoin is mainstream. Nothing else is. And Bitcoin L2s can then actually onboard these new users, grow the pie versus, and that's, again, the advantage of this hybrid design. Because as ETH L2s, sure, everybody's fighting for the same pot of users, same pot of liquidity. And it's fine. You go there, but you're fighting at the big table. It's a tough battle, right? That's what Bob is doing right now. But you're playing at the big high stakes table. But at the same time, you have this massive advantage that you actually can tap into Bitcoin that nobody else actually can. And that's essentially the play for Bob, right? That's why we believe this hybrid design, both in its go-to-market and its ultimate final stage, it has the potential to actually, bring innovation back to Bitcoin and also get more users into Web3 and into DeFi.
Alexei, absolutely phenomenal. It's been fantastic just listening. I could sit here for another 3 hours just soaking everything in. But I guess one final question I'd have for you is for the developers that are listening, as well as any of just the users that are curious, what's the best way for developers to partner and support Bob as well as BitVM? And then what's the best place for users to kind of interact with Bob?
So for developers, super easy. Bob is a OP stack. So, if you're coming from the Ethereum side, it'll all be familiar, super easy. And then what we do is we have the Bob SDK, which gives you all sorts of Bitcoin tooling in a way that you can interact with Bitcoin from within your smart contracts, be it if you just want to verify Bitcoin transactions and verify things that happen on Bitcoin, or whether you want to use our Bob Stake portal and SDK to allow users to one-click deploy the Bitcoin into whatever app you have, be it Bitcoin staking, lending, DEX, AMM, liquidity, or something more complex. You can already access these tools, and they're made readily accessible, and they're built in a way that the APIs resemble things like that you're familiar with from Ethereum staking. So it's really built in a way that is super easy to get started. On the BitVM side, it's quite early. It's really like low-level engineering mostly right now. I can highly recommend taking a look at the BitVM paper. Like, the first sections are actually written in a way that you can get started, understand how it works. And then, sure, if you want to dig into the details of like how exactly Bitcoin transactions look like, then you can, or you just stop there and say, okay, I know the concept, just like with ZK proofs, right? You can understand what they do, the properties, but you don't have to understand everything after that. And ultimately, you won't really notice. Like, you will know that, okay, this thing can be verified on Bitcoin and through a fraud proof, like we can prevent failures, and you just use that as a black box ultimately, right? Sure, you can look at the code, and for those who are more familiar, that's why we essentially helped write this BitVM2 paper. So there is like this one spec that everybody can refer to and understand, and from there you'll have better documentation and better explainers. So probably right now that's, it's still a bit of a like tough learning curve, but it's much better now, I think, than it was like 6 months ago. And like for users, I think the easiest way is just go and check out Bob's ecosystem. So go try Bob Stake. Again, whether you should or should not stake your Bitcoin, that is up to you. But if you're interested in doing that, try it out, because this makes your life so much easier. Like, instead of doing 5-6 transactions across 5 different interfaces, it's one transaction, and you actually will be able to use this from your favorite wallets or your favorite staking aggregator. So right now you already have staking rewards that will support this, but there's many, many more that we'll be announcing over the next couple of weeks. That just makes it easier for you to use Bitcoin in DeFi, and solves this kind of onboarding problem.
Well, thank you so much for taking the time, Alexei. I just got to say, on a personal level, I am always bullish on big brain builders, and you are certainly at the top of this list. I mean, especially the chef's kiss was, Bob being Wadib. So, I mean, this was an incredible episode. No, I know it's still. I'm a big fan of Dune.
No, we're not saying that. We're not saying
I know,
that, of course, no.
But, but I as a Dune fan and as a Frank Herbert fan, that was a great reference too. So thank you so much for taking the time to join us on an episode of Decentral Lounge. Thank you for everybody who's tuning in to watch us on video on YouTube, or if you're listening on Apple Podcasts or Spotify or anything else. We appreciate you tuning into Decentral Lounge. Get in touch with Alexei and the Bob team. It's really, I use it all the time. It's a great protocol, and I look forward to continuing to use it in the future. And thanks so much, everybody watching. Take care, everybody. We'll see you next time on Decentral Lounge.